Imagine your brain as a high-stakes 24-hour mission control center, where the dopamine delivery service is currently navigating a bit of a traffic jam. When we talk about the inner workings of attention deficit hyperactivity disorder, we're really diving into a fascinating dopaminergic imbalance. This isn't just a simple on-off switch, it's a complex coordination between the forebrain, the basal ganglia, and the heavy hitters like the prefrontal cortex and the anterior cingulate cortex. Even the insula, the amygdala, and the cerebellum are part of this network, working over time to manage focus and emotions. The current pathophysiology tells us that when the dopaminergic system in the frontal cortex gets out of sync, it changes the way we process the world. This is where pharmacotherapy steps in. Whether stimulant medications helping to tune the radio or non-stimulant medications focusing on the neurodevelopmental pathways, the goal is to bring a little harmony back to the right inferior frontal cortex. Interestingly, even mindfulness-based cognitive therapy is showing up as a powerful co-pilot, helping to retrain prefrontal pathways to stay the course. But the brain doesn't live in a vacuum. If the dopaminergic system is the software, the neuroimmune system is the hardware. And in neurodevelopmental disorders like Autism Spectrum Disorder, that hardware can get a little spicy. We're starting to see how microRNA and immune cell traffic act as messengers between the intestinal barrier and the blood-brain barrier. When neuroinflammation kicks in, it's like a cellular alarm system. Adhesion factors and cell adhesion molecules start acting like biological glue, influencing glial behavior and releasing a flurry of cytokines. This immune activation doesn't just stay quiet, it talks directly to our signaling pathways. It chats with glutamate receptors, specifically the ionotropic N-methyl-D aspartate subunit 2A, and influences things like vascular endothelial growth factor and voltage-gated calcium channels. It even recruits focal adhesion kinase to help manage the structural changes. It's a full-on conversation between your immune system and your synapses. It's an incredible interconnected web where the notch pathway and wingless signaling pathways act as the master architects using transmembrane ligands to decide which cells become neurons and where they should go. Every single moment, your brain is balancing dopamine levels, managing immune traffic across barriers, and using ancient signaling cascades to keep your neural architects standing tall. Mission Control is currently busy managing $1 trillion biological budget, and sometimes even the best managers need a little help balancing the books.